Would you believe me if I told you that this beautiful ruby was found inside a rock like this? Right now on your screen, you're seeing a piece of white marble, a plain, chalky-looking rock that seems completely ordinary in nature. No sparkle, no special shape, the kind of stone you find on hiking trails, in river gravels, or even scattered along dirt roads across many regions of the United States. Most people walk right past these rocks without giving them a second thought. But what if I told you that inside these dull, lifeless stones could be rubies, sapphires, and even gems worth thousands of dollars? That's exactly what only a handful of gem hunters know, and it's what we're going to reveal in this video. Because what looks worthless on the outside can, in reality, hide a mineral fortune. We're not talking about buried treasure stories or exaggerated legends. We're talking about geology, real formations of the Earth's crust that, under the right conditions, create crystals of extraordinary value. And here's the best part. You don't need to be in a world-famous mine on the other side of the planet. These rocks show up right here in the United States, on mountain trails, in riverbeds anyone can access, and on slopes that most people ignore. Now stop and think for a moment. How many times have you kicked a random rock while walking, or passed by a pile of stones without noticing? For 99% of people, those rocks mean nothing. But for the 1% who learn to recognize the signs, that ordinary moment could be the start of an incredible discovery. That's how amateur prospectors, curious geologists, and even families on a simple day trip have stumbled upon stones that completely change their lives. Of course, it's not easy. Finding rubies or sapphires in ordinary rocks doesn't happen every day. But here's a practical comparison. Your odds of recognizing one of these host rocks and finding a valuable gem are much better than winning the lottery. Because in this case, it's not just about luck, it's about knowledge, observation, and practice. Those who know where to look and what to look for multiply their chances of success. So in this video, we're going straight to the point. We'll reveal the 5 types of rocks that most people ignore, but that can hide rubies, sapphires, and other precious stones. You'll see real field footage, metamorphic rocks with corundum locked inside, dull blocks of marble that hide rubies of exceptional purity, pegmatites with cavities where colorful crystals grow, dark basalts that carry gemstones during volcanic eruptions, and even river gravels that act like the Earth's natural sieves. By the end of this journey, you'll know how to recognize the 5 types of rocks most likely to host or point toward precious gems. This isn't a miracle manual or a promise of instant riches. It's the first real step for anyone who wants to explore nature with a trained eye. You'll understand why indicator minerals like mica, garnet, or actinolite are clues that something valuable may be nearby. And you'll learn which textures, lusters, and geological structures deserve closer inspection. The most important thing to understand is this. The Earth doesn't display its greatest treasures like a store window. It hides them, disguises them, camouflages them. And it's up to us to learn how to read those signs. While millions of people walk past these stones without noticing, a few sharp-eyed explorers manage to find rubies in marble, sapphires in schist, and even diamonds in river gravels. That's the difference between coming home with nothing more than a hiking memory, or with a stone that could be worth thousands of dollars, especially because in many areas, high-value gems are simply not present. Knowing where to focus is the key, and that's exactly what we're about to explore. How to turn an ordinary eye into the eye of a gem hunter. Practical, realistic, and without the fantasy. So if you think all those stones you see on screen right now are worthless, get ready. Because in the next parts, each one will reveal secrets hidden for millions of years. And after this video, you may never look at a trail rock, a river pebble, or a mountain wall the same way again. The first step in our journey is to clear up a detail most people don't know. Rubies and sapphires are not different minerals. They're both variations of the same crystal, corundum, formed from aluminum and oxygen under extreme heat and pressure. The difference lies in the trace elements inside. When chromium is present, corundum takes on the deep red we call ruby. When iron and titanium are involved, the result is blue, pink, yellow, or even green sapphires. So where exactly do these crystals hide? In metamorphic rocks such as gneiss, marble, and especially schist. These rocks don't appear ready-made. They're the result of ancient geological transformations, where existing minerals were reshaped under heat and pressure. It's in this environment of forced recrystallization that corundum finds the space to grow. On your screen now is an example of gneiss. At first glance, it just looks like a rough gray stone with dark and light stripes, almost like a distorted granite. But those parallel bands, called metamorphic banding, can sometimes host small crystals of ruby or sapphire. They rarely show up in obvious ways. Most of the time, they appear as faint red, pink, or bluish spots, often alongside minerals like mica and feldspar. Schist, on the other hand, looks very different. This rock is softer, breaking into thin sheets almost like pages in a book. Under sunlight, it can display a subtle metallic shimmer, thanks to the high amount of mica inside. And this is exactly the kind of rock where many gem hunters find raw sapphires. Look closely, and you may see corundum as small hexagonal prisms embedded in contrast with the layered texture of schist. Marble, which can also host rubies of exceptional purity, will be the focus of the next part. Here, though, our attention stays on gneiss and schist, because these two rocks are far more common on trails, road cuts, and mountain slopes. Often, corundum crystals are partly exposed in fractured surfaces or in boulders rolled down into rivers. And only those who know what to look for can tell them apart from a simple stain of color. And don't think these environments are restricted to far-off places. In fact, they're found right here. North Carolina is well known for sapphire and ruby deposits in metamorphic schists. Visitors can still collect crystals directly from alluvial gravels derived from these rocks. In Montana, sapphires are found both in river gravels and in exposed fragments of gneiss and schist in the mountains. And in the Yukon, Canada, ancient glaciers ripped metamorphic boulders from the ground and spread them across rivers, where rubies and sapphires can still be collected today. What all these examples share is simple. Rubies and sapphires don't shine on the surface. They're almost always found alongside indicator minerals. If you see shiny mica, small rounded garnets, or whitish feldspar in abundance, the odds of corundum nearby increase. These mineral associations are the geological breadcrumbs that trained eyes know how to follow. So how do you identify them in the field? Focus on three main signs. Rock structure, gneiss shows parallel bands, schist breaks into thin sheets, visible crystals. Look for small hexagonal shapes or faint red and blue patches. Companion minerals. If you spot rounded garnets, metallic mica, or pale feldspar, stop and take a closer look. It's not uncommon for beginners to throw away a valuable rock just because it looks imperfect, or because the ruby only appears as a tiny patch of color. But the truth is, even small crystals can reach significant values. A pale blue sapphire or a bean-sized ruby, if transparent enough, can be cut into gems worth hundreds or even thousands of dollars. The idea is simple. Learn how to tell the ordinary from the rare. And from here, we move on to an even subtler type of rock, one that has produced some of the purest rubies in history, marble. On your screen now is a block of raw white marble. Nothing like the polished surfaces we see in kitchens, bathrooms, or famous sculptures. This one has no shine, no finish. It looks like a dull, worthless chunk of stone. And that's exactly what confuses most people. The marble used in construction is simply the same material cut and polished until it reaches that elegant sheen. In nature, though, marble appears as an opaque, whitish rock, often with gray or yellowish streaks, looking common and unremarkable. But behind this plain appearance, marble hides a secret that can turn an ordinary rock into one of the most valuable finds for a gem hunter. That's because the chemical makeup of marble, created when limestone transforms under high heat and pressure, has very low silica content. The lack of silica creates the perfect environment for corundum, the mineral that becomes rubies and sapphires, to grow cleaner and with fewer inclusions. In other words, when corundum forms inside marble, it has a much higher chance of producing top-quality crystals, transparent, vibrant, and intensely colored. That's why some of the most famous rubies in history came from marble deposits. The classic example is the Mogok region in Myanmar, home of the legendary pigeon's blood rubies, prized for their unmatched purity and glow. It's no coincidence. The local marble created the ideal conditions for nearly flawless corundum crystals. Similarly, the Jagdalek Valley in Afghanistan has produced high-quality rubies for centuries. These stones supplied markets across Asia and Europe since medieval times, admired for their strong color and transparency. Often, small rubies are found embedded in veins or recrystallized zones, only showing their true potential after being cut. So how do you identify raw marble in the field? First, forget the polished look. Natural marble is dull, not glassy. Its color tends to be white, beige, or grayish, with irregular blotches. It's relatively soft compared to other metamorphic rocks. If you scratch it with a steel blade, it marks easily, unlike quartz or feldspar. Another important clue is its reaction to weak acids. Being mostly calcium carbonate, marble will fizz slightly with vinegar or other mild acids. But the most valuable clue lies in the crystal inclusions. A seemingly ordinary marble may show faint reddish, pinkish, or bluish spots. These could be fragments of corundum, and that's where trained eyes make all the difference. In some cases, the crystal is partly exposed, showing hexagonal prisms. In others, only a hint of color suggests its presence. To confirm, hardness is a key test. Marble scratches easily, while corundum ranks 9 on the Mohs scale, almost impossible to scratch. If the colored patch resists, it could very well be ruby or sapphire. Another factor is the surrounding geology. Areas with a history of contact metamorphism, where intruding magma altered ancient limestone, are the best settings. If you see recrystallized carbonate rocks, minerals like mica or garnet nearby, and whitish blocks resembling raw marble, your odds go up. Even in world-famous deposits, gem-quality rubies are rare compared to the volume of marble. For every transparent crystal, dozens of opaque or pale fragments appear. But patience and careful observation pay off. Small rubies in marble matrix are valuable to collectors and researchers, and even modest transparent stones can command significant prices once cut. As you see footage of raw marble blocks on screen, the contrast becomes clear. To untrained eyes, it's just another dull rock. To those who understand geology, it's a high-potential environment. The beauty is recognizing that when the earth transforms simple limestone into marble, it creates the perfect stage for some of the world's most extraordinary rubies. On screen now is a light-colored rock with whitish patches and irregular crystals embedded in it. At first glance, it looks like nothing more than a lump of quartz. But this is actually pegmatite, one of the most important rocks for anyone searching for gemstones. Pegmatite is a type of igneous rock that forms when magma cools extremely slowly deep underground. This prolonged cooling allows minerals to grow much larger than in other igneous rocks. The result is a rock that often looks chaotic, made up of oversized crystals of quartz, feldspar, and mica. And in between, nature sometimes hides real treasures. Tourmalines, topaz, aquamarine, emerald beryl, apatite, and in rare cases, even unusual sapphires. That's why pegmatites are often called gem nurseries. They represent the last phase of magma crystallization, when volatile, element-rich fluids penetrate cracks and fractures, creating the perfect conditions for rare minerals to grow in vibrant colors. So how do you recognize pegmatite in the field? The first clue is its pale coloring, usually dominated by milky quartz. Unlike the transparent quartz used in jewelry, this type looks opaque, whitish, or cloudy, almost like frosted ice. Mixed into it are irregular veins of feldspar, often pink or gray, along with shiny flakes of mica that catch the light. Another classic sign is the presence of vugs, small cavities inside the rock. These act as tiny crystal chambers, where pressure and chemistry allow gem crystals to form undisturbed. Open a pegmatite, and it's not unusual to find pockets lined with colorful, well-formed crystals. This is where green and pink tourmalines, clear topaz, and sky blue aquamarines often appear. In the United States, pegmatites are well known in San Diego County, California, where tourmaline and aquamarine have been mined for decades. Maine also has historic pegmatite fields, where collectors still find cuttable crystals. Worldwide, pegmatites in Minas Gerais, Brazil, have produced some of the most valuable tourmalines, including the rare Paraíba variety. And though unusual, pegmatites have even been linked to sapphires of atypical colors, greens, yellows, and blends rarely seen elsewhere. What sets pegmatite apart from common granite is this abundance of unusual minerals. While granite has small, uniform crystals, pegmatite shows oversized quartz and feldspar with pockets of colorful gems. If you come across a light-colored rock with messy veins, shiny fresh fractures, and tiny cavities, there's a good chance it's pegmatite. Another detail: pegmatite is tough to break, but when it does, the fractures often reveal glassy reflections and smooth surfaces, evidence of large crystals inside. Some gem hunters carefully break weathered blocks with hammers and chisels, hoping to expose vugs with intact crystals. It's important to note that not every pegmatite holds valuable gems. Most only contain quartz, feldspar, and mica, but recognizing the right signs, unusual colors, reflective fractures, and crystal-lined cavities is what separates a worthless block from one that could yield cuttable stones. And pegmatites aren't just gem sources in place. Their erosion spreads crystals into surrounding soils and riverbeds. Loose tourmalines, topaz, and even sapphires sometimes show up in gravels derived from pegmatites. So if you can identify the host rock, you gain an advantage in secondary prospecting too. As you see real footage of pegmatites in the field, the message is simple. Don't underestimate those pale, messy-looking rocks. Among the milky quartz and sheets of mica could be a yellow sapphire, a rare tourmaline, or a clear topaz of real value. While pegmatite works like a quiet nursery, growing crystals deep underground, basalt is the exact opposite, the result of violent eruptions, capable of carrying gemstones from the Earth's depths straight to the surface. Basalt is a dark volcanic rock formed when extremely hot, basaltic magma reaches the surface and cools rapidly. This explosive process doesn't just solidify lava, it can also carry minerals that formed at depth. That's how crystals of corundum, which become sapphires or rubies, and even diamonds can be transported to places people can actually reach. On screen now, you can see a typical piece of basalt. Notice the vesicular texture, full of small rounded holes. These cavities are gas bubbles trapped as the lava cooled, now preserved inside the rock. The dark, almost scorched look and the porous surface are unmistakable. This kind of host rock can hide valuable minerals along its fractures, and once it weathers, it releases crystals that end up concentrated in nearby river gravels. One of the most common minerals in basalt is olivine, which in gem quality is known as peridot. These green glassy crystals can be found embedded in fresh basalt or loose in volcanic sands, like the famous lava beaches of Hawaii. Beyond peridot, basalts can also contain sapphires, often in more varied colors, bluish gray, green, or yellow, and zircons, tough crystals that survive transport and show hues from reddish brown to golden. In some parts of the world, basaltic flows produce legendary occurrences. Montana in the United States is a classic example. Its sapphires were found in alluvial deposits formed by the erosion of corundum-bearing basalts. To this day, hobbyists visit rivers like the Missouri and Rock Creek in search of crystals carried by the water. In Africa, especially Tanzania and Madagascar, valuable rubies have been discovered in ancient basalts exposed by millions of years of weathering. These deposits prove that, when an eruption happens under the right conditions, even high-value gems can be delivered right into a careful hunter's path. So how do you turn this knowledge into field practice? The key is to watch for derived gravels. As basalt breaks down under weather, rain, and abrasion, it releases the crystals locked inside. Those denser fragments are transported into riverbeds and settle in what prospectors call trap points, inside bends, behind large boulders, or anywhere the current slows. That's where simple hand screens are used to separate heavy minerals from ordinary gravel. The technique is straightforward. Collect material from the river bottom, ideally in areas where basalt outcrops along the banks or on nearby slopes, and wash the gravel in a screen. Light material like sand and small pebbles flushes away, while denser crystals stay behind. With patience, the glassy flash of a sapphire, the translucent green of a peridot, or even the vivid red of a ruby can stand out from the common grains. Another practical approach is to look for visual signs of old basalt in the landscape. Volcanic hillsides often show dark blocks with angular fractures and rounded vesicles. In some places, the rock faces look fire-scorched, a clue to rapid lava cooling. That's your cue to start investigating. If local geology confirms basalts tied to deep intrusions, the odds of gem occurrences rise significantly. Of course, not every basalt flow holds corundum or diamonds. Most contain only common silicates like feldspars and pyroxenes. But the logic is simple. Where there's a history of basaltic eruptions, there's a chance of transport-resistant gems. That's why experienced prospectors often follow volcanic rocks to locate secondary deposits. As the footage shows screened gravels from Montana and basaltic terrains in Tanzania, the takeaway is clear. This is knowledge turned into action. What looks like an ordinary river to most people can, to trained eyes, be a place where nature concentrated small but valuable gemstones. And since we've looked at formation environments, marble, gneiss, schist, pegmatite, and now basalt, the next step is to focus on the concentration process itself. River gravels, the Earth's natural sieves that reveal gems hidden among apparently ordinary stones. So, after seeing how rocks like marble, gneiss, schist, pegmatite, and basalt act as gem hosts, we arrive at one of the most accessible, practical settings for anyone searching for precious stones: river gravels. This is where nature quietly does, on its own, what miners spend fortunes trying to replicate with machinery. Think of a river as a natural sorting machine, running non-stop for thousands or even millions of years. Mountains and outcrops wear down under wind, rain, and temperature changes. Weathering frees crystals that were locked in hard rocks, corundum, garnet, zircon, and, little by little, the water carries them downstream. But water doesn't move all material the same way. Light fragments like quartz sand or bits of limestone are transported easily, while denser minerals resist and accumulate in specific places. That's why gems like rubies, sapphires, garnets, and even diamonds are found in concentrations called alluvial deposits. In practice, a river works like a giant density separator. Where the current is strongest, light material is swept away. Where the flow slows, on inside bends, behind large boulders, or in quiet eddies, heavy minerals settle. These natural trap points are prime targets for seasoned prospectors because they can hold decades or centuries of concentrated heavy material in a small area. So how do you tell a river-worn gemstone from an ordinary pebble? Focus on 3 basic checks. Density. Hold the stone in your hand. If it's small but feels surprisingly heavy, that's a clue. Minerals like corundum, rubies and sapphires, and garnet are much denser than common quartz pebbles. Vitreous luster. Even after long transport, gems keep a characteristic internal shine. Rotate the stone under light and look for a glassy or silky reflection, different from the dull surface of most pebbles. Hardness. A quick test is a bit of sandpaper or the edge of a knife. Ordinary rocks scratch easily. Corundum barely marks at all. If a reddish or bluish patch on the surface doesn't scuff, your odds of ruby or sapphire go up. One important note: gems in river gravels almost never look like jewelry store stones. Sapphires and rubies rolled by water are often rounded and dull, with iron staining or crusts. But beneath that modest exterior, there can be a cuttable crystal of real value. There's no shortage of real-world examples. In North Carolina, collectors and visitors find sapphires of different colors in alluvial deposits, often mixed with rolled quartz and feldspar. These gravels formed as schists and gneisses rich in corundum eroded, sending crystals downstream until the current concentrated them in specific zones. On the other side of the world, in Sri Lanka, rivers and secondary alluvials have supplied rubies and sapphires for centuries. Entire families still work gravels in areas known for corundum concentrations. Many of Asia's famous gems didn't come from deep mines, but straight from fluvial deposits, nature's own vaults. Field technique here is relatively simple and accessible. With a metal or wooden screen, collect material from the riverbed, typically on inside bends or where the flow slackens. After washing the load, lighter grains flush away while heavier stones settle at the bottom of the screen. That's when trained eyes pick out the glassy blue of a sapphire or the subdued red of a river-worn ruby. A word of realism. This isn't fast or guaranteed. Out of 10 buckets of gravel, maybe one holds anything interesting, and often it's just a small garnet or zircon. Still, that uncertainty is part of the tradition, because a single good find can turn hours of screening into an unforgettable discovery. As you watch gravel being washed in North Carolina and Sri Lanka, the message is clear. Rivers are a gem hunter's best ally. Quietly and constantly, they do the heavy lifting of separating common material from precious stones. Our job is to learn the signs, recognize trap points, and apply a few simple field tests. Now imagine this. After watching everything in this video, you go for a walk along a trail or by a riverbank. Suddenly you notice a small colored crystal embedded in a dull, lifeless rock. Could it be just another pebble? Or could it actually be a ruby or sapphire worth thousands of dollars? That moment of doubt is what transforms an ordinary walk into the possibility of an extraordinary discovery. Because sometimes the real value isn't just in the stone itself. It's in recognizing that you may be holding something truly special. That's exactly why we created the book, Gemology Journey for Beginners. It's a practical guide with comparison images, basic field tests, and step-by-step instructions for anyone starting out as a gem hunter. It's the tool that keeps a ruby from ending up in a drawer mistaken for glass or quartz. But if now isn't the right time for you to grab the book, don't worry. You can still subscribe to the channel and follow every new video for free. And here's something to think about. If sapphires and rubies can hide inside such ordinary rocks, how many other gemstones do you think are being overlooked right now, just beneath our feet? That's why in the next video, we're going to explore exactly that. The stones of many colors that almost no one recognizes, but that can be worth just as much as rubies or even diamonds. Good luck, gem hunter.